The Large Magellanic Cloud, known as the LMC, is a nearby satellite galaxy of our own Milky Way. At a distance of around 160,000 light-years, the LMC is the third closest galaxy to us. But the LMC is more than just a nice little sidekick. Because of its location and orientation, the LMC gives us a much more complete view of supernova remnants and star formation than we can see in our own Milky Way. And even though the LMC is much smaller than our galaxy, it has a lot of action going on as far as massive stars exploding. In other words, the LMC is a great place for astronomers to study supernovas and their remnants. Dr. Patrick Slane explains how taking a step back can sometimes help scientists make a big leap forward in our understanding.
Our galaxy, the Milky Way, is shaped like a pancake, a very large pancake. It's about 100,000 light-years in diameter, but only about 1,000 light-years thick. The solar system is located about 27,000 light-years out from the center of the galaxy. The vast majority of things in our galaxy, the stars, massive dust clouds, black holes and binary systems, supernova remnants, are located in this thin disk, so that's where we have to look if we want to see them. The problem is that all this gas and dust in the disk of the galaxy clouds our view by absorbing a lot of the light and other radiation, even at X-ray energies. It's sort of like looking through the thick soup of ground fog that one sometimes sees early on a cool morning. But amazingly, when the fog is just a thin layer, you look up and see the stars even though you can barely see down your own street. This is how it is with the LMC. It's located up away from the disk of our galaxy, so we get a relatively unobscured view. And it's close enough for us to easily see a large star-forming region or supernova remnants that are left behind when some stars explode. Even better, even though the LMC is about 160,000 light-years away, it's only about 500 light-years across. That means that unlike objects in our own galaxy, which are located at distances both large and small from us, the objects in the LMC are all at about the same distance away. Knowing that the objects in the LMC are all about the same distance away, and also knowing just what that distance is, makes them much easier to compare to one another and to understand. And the LMC has lots of recent star formation. It's a great place to go supernova remnant watching.
Now let's take a look at some of the LMC's most famous supernova inhabitants.
N132d is the brightest in the Magellanic Clouds and belongs to a rare class of oxygen-rich remnants. So the oxygen that we breathe on Earth is thought to have come from explosions similar to this one. And then there's DEM L238 and DEM L249. These are two so-called Type 1a supernova remnants, which we believe are formed in binary systems. But these two seem to have blown up in rather different surroundings, and possibly at a younger age than we would have expected. This is important because astronomers use this type of supernova to measure the expansion of the universe, so we need to know if there can be significant differences in this flavor of supernova. And there are other interesting ones too. When we look at the supernova remnant N49 in optical light from Hubble, we see a wild structure of bright filaments. When we look at this with Chandra, we see bright X-rays from the region where the filaments form, and this seems to suggest that the remnant is plowing into dense clouds of material in this region. Its neighboring remnant, N49b, on the other hand, tells us something very different when we look at it in X-rays. This guy has really enormous amounts of magnesium. There's lots of magnesium in the Earth's crust, and it's an essential element for enzyme reactions in biological systems, including the human body. Much of the magnesium in our galaxy may have formed in remnants like N49b. Finally, perhaps the most famous supernova remnant in the LMC is 1987A. This remnant gets its name because astronomers first noticed it in, you guessed it, 1987, and they've been watching it ever since, with lots of telescopes. With Chandra, we're seeing a ring of material that has been heated to millions of degrees as it slams into a cooler ring of stuff that was there before the star exploded.
So astronomers have obviously found a lot of interesting things by looking at the LMC over the years, but they're not done yet. Just recently, a group of astronomers announced they'd come up with a new and important technique to study how powerful supernovas are when they explode.
When we observe a supernova remnant in X-rays, we have an opportunity to see the actual material that was formed in the explosion. This gives us a lot of insight as to how the explosion developed and allows us to predict what the explosion looked like when it occurred. Recently, two groups studying an LMC remnant known as 0509-67.5 made a remarkable breakthrough by combining X-ray and optical observations. The X-ray observations by one group indicate that the remnant was from a particularly energetic Type 1a explosion. Even though the explosion happened nearly 400 years ago, another group of researchers were able to find the original explosion in the form of light echoes from interstellar dust. Like sound waves echoing off a distant canyon wall, this light provides a delayed signal from the original event. The properties revealed by these light echoes indeed show that the explosion was an energetic Type 1a event.
It seems fitting that the Large Magellanic Cloud and its sister galaxy, the Small Magellanic Cloud, were named after the Portuguese navigator Ferdinand Magellan. After all, Magellan and his crew used the southern sky to explore unknown lands across the world. And today, astronomers are using the objects named in his honor to continue to explore the cosmos and learn more about the universe we live in. For more information, visit our website at chandra.harvard.edu.
This was a production of the Chandra X-ray Center, Cambridge, Massachusetts. NASA's Marshall Space Flight Center manages the Chandra program. The Smithsonian Astrophysical Observatory controls science and flight operations from the Chandra X-ray Center.